Hello. Hello. Hello, everyone. Today we're going to learn about the database management system and database relations, and then we'll solve some of the problems. Well, in database relation, as you can see, there's a table over here, and you have employee ID, employee name, employee's post, employee's salary. Okay. So this relation is called employee, and each row of the table, which is this even Rahul Clark, this whole row in this table is called a record or tuple. Each column is called an attribute, which means this employee ID, employee name, post, salary. This column is called an attribute that represents the employee ID, employee name, post, and salary. Then you have something called domain. So domain means a set of permissible values that can be accepted by a specific attribute. So let's say salary. If you enter the data for the employee's salary, it should range between 5,000 to 1 lakh. So that is the domain. Domains means the range of the permissible values that can be accepted by a specific attribute. So attribute is this. This is the attribute. Okay, the smallest unit of data in the table is the individual data item or cell. So these individual items are called cells, like 2,000, 20,000, 80,000. These are cells. So um, then you have something called primary key, which is always unique. So each of these records will have a key through which you can get only that particular item, because there could be multiple people with the same name. So if you want to get a particular employee, there has to be something unique about it. So employee ID is the unique key, and that's called primary key. Okay, and then you have the degree, which is number of columns. Okay, so this has 4 columns. So the database relation degree is 4. And cardinality is basically the number of rows. So there are 4 rows. So this is 4. Cardinality is 4. Okay, so to give you just a recap, each row is called a record or a tuple. Each column is called an attribute. Each cell is called a domain. So sorry, it's called a data item or cell, and the range of that particular data is called a domain. Okay. So Sumaya, I'm just covering the basics, and then you can start and take it from there. Okay.
Okay.
So database relations, the total number of attributes that comprise a relation is known as the degree of the table. For example, employee has 4 attributes, which means 4 columns, so the degree is 4. Superkey is an attribute or a set of attributes used to identify records uniquely in a relation. Example, employee ID is a superkey since employee ID is unique for each tuple or record. Similarly, employee ID and e-name, employee ID and post are also called superkeys of relation employee since their combination is also unique. Okay, so basically, the difference between the super key and the primary key is that primary key will always be single and unique, but the super key can be a combination of 2 or more keys. Okay, sometimes there will be a scenario where you may not have a primary key, wherein the ID will also be like repetitive. Then in that case, you can combine 2 or 3 columns together and then construct the key. For example, employee ID post, and that becomes a super key, or employee ID and name, that becomes a super key. Then you have something called candidate key. Well, candidate key is a single key or a group of multiple key that uniquely identifies the rows in the table. Example, employee ID and name can act as the candidate key for as long as they contain unique and non-null values. Primary key is the candidate key selected by the database administrator, uniquely identify the tuples of the table. Out of all candidate keys that can be possible for a table, there can only be one key which will be used to retrieve the unique tuples from the table. For example, employee ID and name are candidate keys, but only one can be primary key, which is employee ID. So database administrator chooses which will be the primary key out of all the candidate keys. When you talk about the relational schema, so the database relation is defined using two basic aspects. One is relational schema R, denoted by R, specifies the relation name and the list of the attributes of the relation and the domain of each attribute, which is denoted by R, A1, A2, up to AN. So in the previous example, the relation name was a student. The relation R has n attributes. So what are attributes? We learned about the attributes that each column is called an attribute. Okay. So the relation R has n attributes, which means n number of columns, which is also called a degree of relation. So as I discussed earlier, that previous one had 4 columns, so 4 degree of relation is 4. For example, the relation schema of the relation person can be defined as person ID, name, age, address. So this is the schema, which basically has relation name, so the relation name, and list of the attributes of the relation. So list of the attributes. So attributes column name is person ID, character, and age and address, and the domain of each attribute. So you have integer, character, integer, character. Since the person contains 4 attributes, so the degree is 4. Relational instance. So this was a schema, and then you have something called instance. So relation instance or state is a collection of tuples, collection of rows for a given relational schema at a specific point of time. A relational state or R of the relation schema, denoted by R, is a set of n tuples. So tuples means number of rows. So R equals T1, T2 up to Tm has m tuples, number of rows is m, where n tuple is an ordered list of n values. T equals angle bracket v1, v2 up to vn, where each vi belongs to the domain ai and contains null values or contains null values. So relation schema for student, this is your schema. Relational instance, so instance you have student, roll number, name. So these are your attributes, and these are your rows or tuple. And this is T1 is the whole tuple over here. T1, T2, these are your tuples. Okay. Okay, I'm going to skip that. Or let's go with this maybe. What are different attributes of relation S and how many tuples S has? So attributes means number of columns. So number of columns is 3. So this relation S has 3 columns, so 3 attributes, which are S number, S name, and S city. How many tuples does it have? Tuples means number of rows, so 2 tuples, S1 and S2. This whole thing. Okay. What's the degree of this relation? The degree is 3 because there are 3 columns or attributes. What are domains of the S attributes? Domain is the range. So I think for the S name, for city it will be Delhi. Okay, domain of SNO is the codes that are being assigned to the supplier. So S number will be the code starting from S1. The present coding uses first character as S followed by the sequence number of suppliers. The domain S name is a string of characters of some defined length, and the domain city is a set of possible cities in India. On sorting this relation on the field city, will the relation change? will the order of tuples in the relation change? So when you're sorting the relation on the field city, will the relation change? The relation will not change, but the order will definitely change. If you're sorting it, then row 1 can go to row 2 and row 2 can go to row 1 and so on and so forth. List the super keys and all the possible candidate keys of the primary key of the relation. So super keys will be S number, S name, S city, S number, S name, S number, and city. So the combination of these. Candidate key will be S number, S name, and primary key will be S number. Okay, let's see. Yeah, I think now we're going to do, we should do ER diagram, ER model. So an ER means entity relationship model, the analysis model of a database system. So this basically analyzes a database system. So entity relationship model is a high-level conceptual data model. It allows you to describe the data involved in a real-world enterprise terms of entities and relationship. It is widely used to create an initial design of a database. It provides a set of useful concepts that make it convenient for a developer to move from a basic set of information to a detailed and precise description of information. It describes the data as entities, attributes, and relationships. So this is your ER model. In the ER model, you have entity, attributes, and relationships. Suppose we design a school database. In this database, the student will be an entity. Okay, so the student will be an entity um, with attributes like address, age, ID, and name. Okay, so these are your attributes, and attributes are basically in the diagram denoted by this shape, and the entity is denoted by this rectangle. The address can be another entity with attributes like city, street name, pin code, etc., and there will be a relationship between them. Okay, so entity may be in any object, class, person, or place. In an ER diagram, entity relationship diagram, an entity can be represented as rectangles. Okay, so this is your uh, entity. This is also an entity, but it's a different type of entity. I'll just show you in a moment. Consider an organization as an example. Manager, product, employee, department can be taken as an entity. Entity set or type. A collection of similar kind of entities is called entity set. So entity set is nothing but a collection of different entities or entity type. Example, a collection of all the student entities form a student. Entity identifier, an attribute or a set of attributes which attains unique value for every distinct entity is a set and are called key attributes. And its value can be used to identify each entity uniquely in a given set. So one attribute or a set of attributes, if they have a unique value for every distinct entity, that is the key attribute. So there are two types of entities. One is weak entity and second is strong entity. So an entity that depends on another entity is called a weak entity. Weak entity does not contain any key attribute of its own. The weak entity is represented by a double triangle. So both are entity, but this is weak entity and this is strong entity. Strong entity, an entity set which contains at least one key attribute, is called a strong entity. For example, a student entity set would contain at least one key attribute, enrollment number, which is unique for every student. Thus, the entity set student is a strong entity set. So the difference between these two, weak entity and strong entity, is that the weak entity does not contain any key attribute, like anything unique of its own, and um, it's represented by double triangle. It's dependent on another entity. Okay, and strong entity contains at least one key attribute, unlike the weak entity. Okay, now I talk about the attributes. So these are your attributes: ID, phone number, age. This is your entity, and this entity has different attributes. Okay, so the attributes is used to describe the property of an entity. Okay, f- and the eclipse shape is used to represent an attribute. For example, ID, age, contact number, name can be attributes of the student. Now, there are different types of attributes. One is simple, which means that an attribute that cannot be further divided into small parts and represents the basic meaning. Example, each of the attributes, first name, last name, age of an entity, set, person, are simple attributes. Composite attributes, an attribute that is composed by dividing it into multiple other attributes. Example, the attribute name of a student entity can be subdivided into first name, last name, and middle name. So here, this is an example of attribute. So all of these are attributes. Name is a simple attribute because, sorry, name is a composite attribute because it is being divided into first name, middle name, and last name. So it is being divided into multiple other attributes. That's why it's a composite attribute. And name is, and first name, middle name, and last name, each of these is a simple attribute because each of these cannot be further divided. You can't divide the first name further. You cannot divide middle name further. So that's why this is simple and this is composite attribute. Then you have single valued entity attribute having a single value. For example, age of student entity. Multi-valued means an entity attribute that have more than one value. For example, student can have more than one phone number. And it is represented by double oval. So when you have multi-valued attribute, it is represented by double oval. And when it's a single value, for example, age or first name or last name, these attributes are single value attribute denoted by just an eclipse. Derived, an attribute that can be derived from other attribute. For example, uh, if you just know someone's date of birth, you'll be able to derive his age from that because you know the current date, today's date. So something that is derived out of that is called a derived attribute, and it is denoted by a dash eclipse. Okay, so age is not actually going to be entered by the user, but you can derive it using the date of birth. Okay, now talk about the relationship with the ER diagram. A relationship is used to describe the relation or association between entities. So you have an entity called teacher and you have an entity called students. There are two different entities, and the relationship between them is teachers. Teach. Example in teacher entity and student entity, teachers is the association relation between them. There are different types of relationships in database. We have one-to-one, where only one instance of an entity is associated with the relationship. For example, a female can marry to one male and a male can marry to one female. It is denoted by 1:1, and this is your ER diagram for that. One to many, when an instance, only one instance of an entity on the left and more than one instance of entity on the right associates with a relationship, then that is called one to many. It is denoted by 1:n. For example, scientists can invent many inventions, but invention is only done by one specific scientist. So this is one to many. Then you have many to one, when more than one instance of an entity on the left and only one instance of entity on the right associates with the relationship. That's called many to one relationship. So it's denoted by m is to 1. For example, a student can enroll for only one course, but one course can be enrolled by multiple students. Many to many, when more than one instance of an entity on the left and more than one instance of the entity on the right associates with the relationship, that's called many to many relationship, denoted by m colon n. For example, an employee can be assigned multiple projects, and multiple projects can be assigned to multiple employees. You have cardinality of the relationship set. It means the number of instances of an entity associated with another entity participating in a relationship. Based on the cardinality, binary relationship can be divided into further following relationship categories: one to one, one to many to one, and many to many. We already discussed that. Then you have degree of a relationship set is a number of participating entities sets. Relationship between two entities is called binary relationship. Relationship among three entities is called ternary relationship. Similarly, relationship among n entities is called n-ary relationship. You have recursive relationship in which both the participating entity sets are the same entity set. However, the role of the entity set in each participation is different. You have participation constraints specify whether the existence of an entity depends on its being related to another entity. Okay, I think now we jump to ER diagrams. So I already shown you some of the examples of ER diagram, but basically they are represented by three main shapes. An entity set, which is basically a group of multiple entities. For example, group of students entities called entity set is denoted by a rectangle. Uh, Attribute is denoted by eclipse. You have multiple example over there also. For example, a single valued by single eclipse, multi-valued by double oval, and derive will be by dash eclipse. Okay, and then you have the relationship set, which is denoted by diamonds. The logical structure of a database is modeled using ER model and is graphically represented with the help of a diagram is called ER diagram. Okay, so the logical structure of database is modeled using ER model and graphically represented with the help of diagram called ER diagram. So entity rectangle, weak entity double, uh, double rectangle, and strong entity by single rectangle. You have attribute. This is derive attribute. When you have double value, a double oval, then it's multi-valued attribute, and this is called key attribute. And then this is relationship. This is identifying relationship. This is composite relationship. This is your entity one, entity two. This is your relationship set. Total participation E2 in ER, participation of E2 in ER. This is an example of a college database where you have an entity called student. It has attributes like roll number, name, and address. Because it's underlined, it's the key attribute. If you notice from this example, it's a key attribute which is unique. Now, student has a relationship with course. Relationship name is ops. And I think it's n is to 1. So it's many is to 1 because student can opt for multiple courses. Then you have the course ID, which is the primary key attribute. Then you have course name and duration of the course. This student basically has the relationship with the guardian entity, and guardian entity is actually a weak entity because it is dependent on the student. And yeah, and these are your attributes for that. And assisted by is the relationship. This is one to many relationship because a student can have one guardian but he can enroll into multiple departments. Okay, so that's your enrolled is the relationship. This end is to one relationship. Its relationship is with the department, which has department number, department name as attributes, and so on and so forth. That's how these are all are interconnected. Okay, so Maya, now you can take it over. I think we've got the basics. I'll stop the share. Okay.
Okay, so I'll do this question from the book.
Okay.
Okay, can you see my screen?
Yes.
Okay, so we have to make an diagram for an employee database. An employee works for a department. If the employee is a manager, then he or she manages the department. Every employee works on at least one or more projects, which are controlled by various departments of a company. An employee can have many dependents.
Okay.
So first we'll list all the possible entities and the attributes that they'll have, and also separately list the relationships. Should I do all that or just skip to making the ER diagram?
Mm, I'm not sure what you're gonna show. Maybe just do a little bit, show a little bit what you mean.
Okay. So usually the questions they ask first to list the entities and
Mm.
list the attributes and the relationships, and then draw the ER diagram.
Right.
So uh, you list the entities, so there would be an
Employee.
employee, department,
Yeah. Projects.
project here, and dependent.
Okay.
So the attributes that the employee can have is ID, name,
Mm-hmm.
address, date of birth, salary, gender.
How do we determine that? Do they give this information what attribute is gonna be, or just we just guess it, like we just assume it?
In some of the questions, they have detailed information. If they don't have, I think we just have to put what makes sense.
Okay.
Department will have department ID, department name,
Mm-hmm.
location, number of employees.
Okay.
Project will have name, project number,
Mm-hmm.
location. Dependent will have name, gender, relationship, and birth date.
Okay.
So the relationships we have between the entities are between employee and department. Employee works for department,
Yeah.
and employee also manages department.
Hmm.
There's a manager from the employee database, from the employee table.
An employee assigned to a project, which will probably have uh,
Yeah, employee
one to
works on
many
project.
relationship. Okay.
Yes, and uh, also employee supervises employee. That's a
Mm-hmm.
one-to-many relationship.
What's the, can you show the question? Like, what's the question in the question paper or in the assignment?
Oh, this is the question that's here. It's from the textbook.
Entire. Okay. Okay. Right. Find all possible entities of relationship. So, and then draw an ER diagram of the above. So there are two parts of this question. Find all possible entities and their relationships. So can you write the relationships?
Yeah.
Okay.
Employee who works for department.
Mm.
Employee works on project.
Assigned to, I think it should be right.
Yeah, it was
Okay.
works on in the solution, so I put the same thing. Employee manages department.
What's the difference between works for department and manages department?
There's a manager who manages each department.
Okay.
So not all employees will manage a department, only the managers.
Okay.
And employee supervises.
So
So
they
this
could be
is
team
a
leader, they could be
recursive
supervisor.
relationship.
Okay.
Uh, then we have department controls project.
Mhm.
And dependent. Uh, dependent uh, uh, depends on employee
Should it be employee
or
depends on
dependent of.
dependent? Should it be the other way around?
Uh, the dependent is a weak entity.
Okay.
So I'm not sure actually.
Okay. Let's continue.
I'll just put employee has dependents like how it's in the question.
Okay.
Okay, so those are all the relationships.
Okay. So I think this answers the last sentence of the question, which is find out possible entities and their relationship. Now we have to do the second last line, which is draw an ER
Yeah,
diagram
okay,
of the
ER
above.
diagram.
Yeah.
So there's employee.
Mm. This will be denoted by double triangle,
Yeah,
dependent.
and project.
It's fine. You should be able to send it to back, I believe, once you draw it. You don't have option, right?
I'll just put this like this. Oops.
It's fine.
Okay.
Understood. It's fine. It's understood. It's fine.
Okay, I'll draw the relationships.
Okay. So relation should be denoted by the diamond shape.
Yeah. Employee works for.
It doesn't look like a diamond.
That's the
Looks
best I
like
can do.
looks like India
It's
map.
easier to use the pencil.
Okay.
Employee works for a department, and
Hmm.
this is a total participation relationship, so there should be a double line.
Yeah. What's the total participation?
Uh,
I think I'm missing
Means
that.
every employee has a department, and every department has employees.
Okay. So this will be is it many to many relationship?
This is one to many, many on the employee side. Uh, so n here. So a department can have many employees, but an employee works in only one department.
Yeah, because I think the first line of the question is employee work for a department. If they would
Yeah,
have said multiple department, then would have been many to many.
yeah.
Okay.
Employee manages a department.
Mhm. So there can be like multiple relationship between the two entities.
Yeah. So every employee doesn't manage a department, but every department has a manager. So the double line will be only on this side.
Okay. So one manager can handle multiple departments. But it doesn't say that in the line. We just assuming that, right?
Yes.
Okay.
This is one to one.
If it's one to one, then why is it a total like why is there a double line on the right?
The double line is for total participation, meaning there can't be a department that is not managed by an employee.
Oh, okay, 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 okay. Got it.
And there's a single line here because every employee is not a manager.
Understood.
And the third one is employee supervises employee.
Mm-hmm. So recursive.
Yeah.
Okay.
This one is one to many.
Hmm.
And last, relationship of employee works on a project.
Hmm. I think it's always better to just write down the entities and relationships. It just makes it easier to draw. And I think it's better to write the relationship type also, like one to many and all that. So then at the time of drawing, you can just draw.
Yeah. Actually, when you're showing the relationships, you're supposed to draw the diagram.
Yeah.
Like in your presentation,
Hmm.
you had some diagrams that were just showing relationships between two entities.
Right.
So that's what you're supposed to do.
You mean I've already drawn the ER diagram, so this is already showing the diagram, right? So what else I have to do?
Uh, Draw the diagram of the relationships separately.
Separately. Do we have to do that?
It's done like that in some of the examples, and it
Okay.
makes it easier. Like you can show the participation and the one to many also.
Why I was saying that is because in this ER diagram, in anyways, showing the relationship and the participation and everything.
Yeah, you just repeat that in the ER diagram.
Okay.
So employee works on project is a many to many relationship,
Hmm.
and it has total participation on both sides.
Okay. That's M is to N, right?
Yeah,
I don't know whether why they call it N. They should have just call it N.
called what?
Or is it N to M or M to N?
Um,
Let me see.
I don't think it matters the order.
I don't know why they introduce the concept of N then, if it doesn't matter. I think, in my opinion, M always comes on the left and N comes on the right, as I can see.
Okay.
Yeah. I think that's why they brought the two different names so that they can denote the left and right part, probably.
Okay, so we're done with employee and department controls project.
Hmm.
So this one has total
One too many?
participation on the
Okay.
project side. Yeah, it's
Okay.
one to many.
We just have to assume this, right? This one to many relationship.
Uh, yeah. Sometimes it's there in the question, like in the December question paper. The
Hmm.
question is quite detailed.
Okay. That's it.
And dependent, we have to uh, show the relationships for that. Um, so employee is dependents of.
Depends on. dependent.
Yeah. So this one has total participation on the dependent side. Employee doesn't have to have a dependent,
Okay.
and it's one to many.
Yeah. Why don't you draw the
Yeah,
double
I'll draw that.
rectangle using a pencil? I think we have to also draw the attributes, correct?
Yeah. Okay, we can add the attributes now.
Hmm.
Employee has ID.
What's the difference between relationship and identifying relationship? The double.
The the double line. That's total participation.
No, 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 no. The double on the depends on the eclipse, double eclipse. What's the difference? That's called identifying relationship, right? So, what's the difference
Yeah.
between a normal and identifying relationship?
Identifying relationship is between the owner entity and the weak entity.
Which entity? Sorry.
The owner entity, that's employee in this case, and the weak entity, dependent.
Okay, got it.
Dependent doesn't have any identifying key,
Okay,
so it's identified by the employee key.
okay. So usually when we have a weak entity and there's a relationship, we should use double eclipse. Sorry, uh, double diamond.
Yeah, and a
Correct.
double rectangle.
Okay. And this will be underlined, right? Because it's a key
Yeah.
attribute.
The name. So the name can be a composite attribute.
Okay. Which means employee ID and name can be combined together to form a. Sorry, composite attribute means that it can be
It
divided
means
into
it's made
multiple
up of,
attributes.
yeah,
Yeah,
like
like first name,
first
last
name.
name.
Yeah.
Okay. But we don't have to write all of that. We just have
Okay.
to show it that it's dependent. It's fine. You can write first name, last name. Just put FN just to make it easier.
And we'll put date of birth, address, salary, and gender.
Mm-hmm. Age? Do we not need the age?
The date of birth is there, so age can be a computed attribute.
Derived, you mean?
Yeah,
Called
yeah, derived.
derived. Yeah. So name is sorry, first name and last name. Each of these are which attribute? Simple attribute. Age will also be, I think, date of birth will be simple attribute. Do we have to define so many attributes?
Maybe not.
Okay. But I guess if we show like different types of attributes, it'll yield us good marks because they'll know that we know what types of attributes are there, especially date
Yeah,
of birth. We can probably skip gender, but we can salary. I feel that it's an important attribute. Name is important. Employee ID is important. Date of birth is
yeah, ID is
important.
important.
Yeah. Let's do age after DOB with a dotted dashed.
Okay.
So age will come out of DOB, right?
Uh, I don't think so. Can you check? Or I'll check.
Check, no? Not sure.
In the textbook, it doesn't say, only that it's represented by a dashed. It's,
Hmm. No, no, I'm not about dash. I'm talking about where will it originate from? It is
yeah, there's no
definitely
example.
there's no example.
No.
It is definitely represented by dashed oval shape. That's for sure. But where it originates from, that I'm not sure. Whether it originates from a, I think it should, right? Should originate from date of birth and not from the entity itself because it's derived from that. Don't you think?
Um,
How
okay, I'm seeing
how
some examples
yeah
online.
okay.
It's derived. It's derived from the entity itself, not from the other attribute.
Really? Can you share the link?
Yeah.
Share in comments.
I mean, I sent it in the chat.
Comments. Yeah. Hmm. I don't know why it doesn't make sense. But anyways, let's continue.
Okay, I'll put the attributes for department now. Department ID, department name, and location.
I think we don't need to put. It's fine. It's understood. We have
Okay.
done one, so similarly we have to do for that also.
Okay. And department has another derived attribute number of employees.
Derived attribute number of employees. Okay. Okay.
Then dependent has name, gender, relationship, and birth date. Project has name, project number. Project number is the primary key, and location.
Maybe just create a big text box here and just write the names of those attributes,
Okay.
and it's understood that we can draw it. Number of employee is the derived, right?
Yeah.
Okay. So we'll use that dashed oval shaped. Okay. Project number is the key attribute.
Yeah. Dependent name, gender, relationship, and date of birth. The relationships also have some attributes in the solution that the book has given.
Where is relationship? Okay, relationship themselves
These
have attributes.
times, yeah. So works. Oh, this should have been works on project, not works for. Works on project has the attribute hours.
How do you create that using that oval shape only?
Yeah, like this. And manages has start date. So they've not mentioned this in the question. I don't know why they've put all this in the solution.
Yeah, not required, I think.
Yeah,
Which question number is this?
it's let me check.
Hmm.
It's question 2 in on page then page numbers page
Page
14.
number. I mean, are you giving me? So, is this question from the textbook or is it from the
Yeah,
assignment?
it's from the textbook.
Oh,
The
okay,
assignment was even more complicated.
okay, okay. That's why we wanted to do assignment because assignment is complicated.
I did that, but I'm not sure if it's completely correct, so I
It's
decided
fine,
to
I
do
think.
this one.
At least we know how to draw the ER diagram. Now, how to convert? I think there's a question in the assignment to convert it into a table, right?
Yeah,
Uh,
to convert it
design
into relations.
design a normalized table 3NF from ER diagram. So I don't know what 3NF is with the required integrity constraints.
3NF is third normal form. I've not finished studying
Okay,
normalization
normalization.
still.
Okay. Normalization basically relationship. For example, if one table has multiple entries of a same record, like a five different subjects, if you put my details into for five different subjects, so there could be like three different records for me. My name and then the subject name and subject details. Again, my name, again subject details, again. So it's a repetition. So it's not
Yeah,
very. It's like data redundancy. So for that, to normalize it, what they do is they go ahead and create multiple tables. So
yeah,
that's
I understood the basics of it.
yeah,
I've written the relations for this uh, ER diagram.
no problem. That's fine. Would you be able to solve at least some of the questions from the question paper? Can you take a look at it and tell me if you're able to
Uh,
solve, or you'll require time for that? Just
the first
maybe
one I can do. I already did that.
let's do that then. I sent you the link in the chat. Maybe tomorrow you can do the assignment questions where they want us to like draw the tables out of the ER diagram. I think that's one I'm struggling with. Well,
Okay.
to convert the ER diagram into tables. There are
I
list of
could do that
questions.
for this ER diagram.
Okay. Uh, because question
Should I
number
do it
two.
now?
Yeah, you can do it. Design normalized table 3NF form from ER diagram.
So basically, what I understood from normalization is that if you follow certain rules while converting it into relations, it's automatically in third normal form, and you don't have to normalize it further.
Okay. Now, what did you say 3NF means? The third normalized form
Third
means?
no, third normal form.
Means what? Like,
Uh,
what does it mean?
so it hold on. I don't know how to explain it exactly now.
Sorry?
I don't know how to explain it in simple terms.
That's fine. I
Uh,
think we'll probably leave that until you've properly studied that part because,
okay.
yeah, there were several other questions. Like, there's a third question. Let me share the assignment link with you first. So, there is a third question. Consider software management system maintains database using following table. Find the CID, C name of clients who have given the project. I think this is easy, right? This no, this is fine. You don't have to do that. Okay, let's jump onto the question paper for now.
Okay.
Yeah.
So the first question is: a university is planning to maintain the following details: a unique
Mhm.
student identification, name of the student, program
Would
coordinate,
you
student
share your
address,
screen
and
and
role.
then show that?
Okay.
I've shared the link of that on the chat. This is second link.
Okay, can you see my screen?
Yeah.
Um, Program code in which the student has
No.
enrolled, program names, program duration, program fee, the contact phone number of the student, the fee paid by the student along with the date of payment. I list all the entities as per the description. So
So
the
university
entities,
is, one second. University planning to maintain the following details: unique identification number, name of student, program code, all of that. Perform the following tasks. The question start from that one, right?
yeah,
I list all
yeah.
the entities as per the description. Okay, so do we need to draw a table or something for this?
No, I think here we can just list the entities. So we
Okay,
would have student and program. I don't think we need any more entities.
entities. Okay.
I list all the attributes of the entities. So student has student ID, name,
Hmm.
contact number, fee
Program
paid,
code.
and yes, it has a
Program code
relation
also.
to program. So we don't need to specify program code in the student entity.
How do you know it's a relation?
In the year diagram, we'll write student enrolls in program.
No, no, no. From the question, how did you determine that it's a relation?
Uh, a student enrolls in a program. That's
Hmm.
the only relation that we have.
The basically the word enroll, right, shows that it's a relationship.
Yes, and there are two separate entities that you can see, student and program, so they should have some relation.
Okay. So first question is answered, which is will be student and program.
Yeah,
List all the attributes of the entities as per description. So student
okay, and
ID, name,
yeah,
and
contact
inside of name
number.
will be first name, last name, and middle name. That will be
Yeah,
your derived, and contact number, which will be multi-valued attribute.
yeah.
What else?
Fee paid and date of payment also.
Okay. I can't see the question paper on top. It's hidden. Can you scroll up? Yeah, much better. Program names, program duration, program fee, contact number of this. Yeah, this contact number will come there. Fee paid by the student with the date of payment also. So date of payment will also be an attribute, right?
Yeah, of student.
Of student. Okay.
Then program attributes are program code.
Code.
Program code is the primary key.
Hmm.
Program name, duration, and total fee.
Okay.
Then the relationship is there's just one relationship. Student enrolls in program. It's a many to one relationship.
Hmm. Yeah. No, why not many to many?
Uh,
Once one student can enroll into many programs, and one program can have many students. Why not many to many?
yeah, you could do many to many also.
Okay. So ER diagram, we don't have to worry. We just learned how to draw an ER diagram, so which is fine.
Yeah.
List all the constraints, including primary and foreign keys. So what will
So
be the answer?
primary keys would be student ID, program code. Foreign key, student would have a foreign key program code.
Yeah. So student will have program code, and program code is the primary key for program. So it's common between the two. That's how
Yes,
it's a
it's a
foreign
foreign
key.
key for a student.
Okay. So it's saying list all the constraints. So probably they're asking for candidate key, super key, all of those also. right? It's saying including these, which means these plus them. So I guess we also have to list down the candidate key, etc.
Yeah, I guess you could do that.
Okay. Convert ER diagram into relations. Now this is what I want to learn.
Okay, so the way I did that was student has student ID, first name, middle name, last name, contact number, fee paid, date of payment, program code. Student
Let me ask
ID
you
is the
this. On the question number 6 over here, is it asking you to draw a table, or is it asking you, because asking you to convert the diagram into relation, right? So
yeah.
it must be the table, correct?
Uh, it doesn't have to be in the form of a table. In the book, there's the relation name like student, and then in brackets all the attributes are there, and the primary key is underlined.
Can you show in the textbook then the example of the answer?
Yeah,
Okay.
just a second.
Hmm.
Like this.
Okay. Thus,
So
final
below
relations would be.
each
Mhm.
relation, they've also mentioned the foreign key and the constraints.
Wait, I'm just reading. Abandoned. Employee, department, dependent. But they have not like mentioned anything. What is relation? Whose relation? It's just this looks like a schema to me.
Yeah, it is a schema. So each table is called a relation, right?
Yeah, just go above. Yeah, this looks like a relation to me. This looks like a relation. Employee name, you have a schema, and then works for. And due to this relationship, primary will add the employee. Okay. I'm not sure if this is how you need to do it.
This is just an explanation, I think, and these are the final relations.
Okay. Okay. That's fine.
So when you're making relations of one to many,
Mm-hmm.
a relationship, then the foreign key goes on the many side.
Okay.
So for the student program, I did it as a one to many relationship. So I put program code in the student relation.
If you
Let
put
me share that
program code
screen again.
in the student relation, uh, see, student table needs to have program code as a foreign key, and the program needs to have the student code. Sorry, what did you say? Program code, yeah. Program relation needs to have the program code as the primary key, correct?
Yes.
Okay. There's one more question if you know the answer of that. So in the question paper, there's a question number 4C. Let me check that. Yeah, functional dependencies. Have you learned this?
Yeah, this I've just started studying, so I don't know yet.
Okay. So maybe tomorrow what you can do is you can cover this question plus the question from the assignment. You can skip drawing the ER diagram because we already know how to draw that. but you can do
Okay.
the rest of the questions in the same question. So question number you can do is question number 2. A medicine store needs to maintain database system.
Okay.
So you can skip the A part, which is just drawing the ER diagram. We can just copy paste the diagram to show how it looks like, and then do the B, C, D, and all those just tables basically. There's only one the question, I think B, which is draw normalized 3NF. Yeah, correct. And yeah, that's about it, I guess. So if you can cover that, let's take a break for 15 minutes. Let's come back in 15 minutes and continue with our database manage. Sorry, Java. Okay.
Okay.
Yeah, I'll keep this on, and I'll be back in 15 minutes.
Okay.
Okay, I'm back. We'll start. Okay, we'll do a recap today from declaring and implementing an interface. So let's go back a little bit. I think we should start with interface. Yeah, let's color this differently. It's like a checkpoint, and remove the color from the other one. Okay, so what is an interface? Interface is basically a blueprint of a class, and it contains the static constants and abstract methods. So static constants and abstract methods. Okay. In Java, an interface is syntactically similar to classes, but they lack instance variables, and their methods are just declared without having a body. So one of the key difference between a class and an interface is that in interface you don't have the instance variable. Instance variables are those variables which are defined inside of the class but not inside of the method body. And the method are just declared, which means they are not implemented. They are just declared the name of the function in curly braces. There's no body of that. It means that the interface can only contain constants declaration, method declaration, default methods, static methods, etc. Constant declaration, method declaration, default methods, static methods. Okay. What are the advantages of interface? One of the key advantages is it allows us to have the multiple inheritance, which is not supported in Java by default. It is used to achieve the total abstraction. It is used to achieve loose coupling. So total abstraction and loose coupling. Difference between abstract class and interface. Abstract class can have abstract and non-abstract methods. An interface only has abstract methods. Since Java 8, it can have default and static methods. So abstract class has abstract and non-abstract methods. Interface can have only abstract methods. Abstract class doesn't support multiple inheritance. Interface supports multiple inheritance. Abstract class can have final, non-final, static, and non-static variables. Interface only has static and final variables. That's why we have only constants in that and the method without the body. Abstract class can provide implementation of interface. Interface can't provide implementation of an abstract class. The abstract keyword is used to declare abstract class. Interface keyword is used to declare interface. An abstract class can extend another Java class and also implement multiple Java interfaces. An interface can only extend another Java interface. You cannot implement another Java interface. So one of the good differences is that abstract class, you can extend any classes, you can implement interfaces, but interface, you can only extend another interface. You can't you can't implement another interface. Abstract class can be extended using keyword extend. Interface can be implemented using the word implements. Java abstract class can have members like private protected. Members of Java are public by default. Example, public abstract class shape, public abstract void draw, public interface drawable. Declaring and implementing an interface, there's a keyword called interface and then the name of the interface. You declare the constant fields, declare the methods that are abstract by default. And then here we have an interface printable. There's a method inside of it which is not implemented, we just define it. Class A6 implements printable. It must also implement its methods. And inside of the main, we just instantiate the new class, and we call the print method. It provides total abstraction, loose coupling, and multiple inheritance. So three main advantages: multiple inheritance, loose coupling, and total abstraction. Means all the methods of an interface are declared with an empty body, and all the fields are public, static, and final by default. A class can implement an interface using a keyword implements. A class that implements an interface must implement all of its methods. And same is the true for abstract classes also. If if you are extending an abstract class, then you must implement all of its methods. Extending an interface. So we spoke about implementing an interface. Now we talk about extending an interface. So we discussed that an abstract class can extend another class as well as implement an interface, but an interface can only extend an interface, it cannot implement another interface. So now we talk about extending an interface. So one interface extends another interface. So it uses the keyword extends. In this case, a class that implements the extended interface must implement all the methods declared in original and extended interfaces. Let's add animation. Issues of multiple interfaces. Java does not support multiple inheritance. For example, if a class inherits two classes which have the default method, upon calling the method, the compiler cannot determine which class default method to be used. To solve this, we can use multiple interfaces. If both interfaces contains default method with the same signature, the implement class should specify which default method to be used, or should it override by default. And I think we use the super keyword for that. So let's say there's an interface P1, interface P2, then the class test multi implements both of the interfaces together. Then if you want to access the display method of the first interface, you can use p1.super.display. And if you want to do that for the second interface, you can say p2.super.display. Use of static method in an interface. The interface static method is similar to the default method of an interface, where it cannot be overridden in the implementation class. Okay. The static method contains the complete definition of the function, and since definition is complete, the set method becomes static. Therefore, these methods cannot be overridden in the implementation class. So, if we are going to implement an interface, we cannot override the methods which are defined as static. Like, for example, here there's an interface called new interface. Interface demo implements new interface. We can definitely override this override method by redefining it, but we cannot override hello method because it's declared as static. Um, Unnecessary. Multi-threading in Java. So Java by default has the multi-threading feature, which means it allows concurrent execution of two or more parts of the program for maximum utilization of CPU. So what is multi-threading? Multi-threading allows concurrent execution of two or more parts of the program. When two or more parts of the program execute simultaneously, that is multi-threading. And why it's done? Multi-threading helps in maximum utilization of the CPU because multiple parts of the program are running simultaneously. So CPU is keeping the CPU busy. It's not that one program has to wait for another. Each part of the program is called a thread. So threads are lightweight processes within a process. Okay. Multi-threading system in Java is built upon thread class, its method and its companion interface runnable. To create a new thread, your program will either extend thread class or implement a runnable interface. The thread class defines several methods that help in managing the thread. So, what is multi-threading? Multi-threading allows concurrent execution of two or more parts of the program to allow maximum utilization of the CPU. Each part of the program is called a thread, and thread is basically a lightweight process within a process. Multi-threading system is built upon thread class, its methods, and its companion interface called runnable. If you want to create a new thread, you will need to either extend thread class or implement runnable interface. Thread class has several methods which help in managing the thread. How threads are created in Java? Threads can be created by two mechanisms. One is extending the thread class, and second is implementing the runnable interface. As we discussed. So let's take an example. So here we have a class called multi-threading demo. It's a custom class. It's extending thread because we know that we can create a thread using two methods, either by extending thread class or by implementing interface. So in this case, we are extending thread class. This has a method called run. So this run method is already available in thread class. We just redefining, overriding that method to make it do what we want to do. There's a try and catch method. Instead of this, we're just printing thread, and then this class thread has a method called current thread, and that has another method called get id. So this is going to get the id of the current thread which is running at that point of time. If there's any issue with running this, then it's going to catch the exception and print it out. Once we have extended the class, we just have to basically instantiate that class here. We are going to create 8 different objects for that. That is why we are looping through 8 times, and we create an object with the type of multi-threading demo, and then we just instantiate this class. Once we do that, in the object we'll have access to the start method and the run method, all of that. Start method belongs to thread, so we'll just use start. Once we start, that thread will start running, and then whatever the id of that thread is will be displayed over here. And this is available in the java.lang. So you have to import on top, import java.lang.thread. You have to do that import on top. Start invokes run. So when you call start, it invokes run. And that's why these guys are printed. Okay, so we learned about one method, which is by extending thread class. Now we learned about another method of creating a thread, which is implementing the runnable interface. We create a new class which implements java.lang.runnable. So we have to import that and override the run method. Then we instantiate creating an object and call the start method, which will invoke the run method. So it's basically a similar fashion. The difference is that this time, instead of extending the thread class, we're implementing the runnable. Same thing here, whatever we did there. And over here, we are going to create the object 8 times. Well, that's why we're looping it eight times. And then inside of the new thread, we have to pass the class that is implemented as a parameter, as basically an object of this class. So new multi-thread demo is going to return an object of this class, and that is an object we are going to pass into this thread and call the method of start, and that's doing the same thing. Okay, thread synchronization in Java. If you want two threads to communicate and share complicated data structures such as a link list or graph, you need some way to ensure they do not conflict with each other. So you must prevent one thread from writing the data while another thread is in the middle of reading it. So there's a need to synchronize the action of multiple threads and make sure that one thread can access the resource at a given point of time. Should be one thread can access one resource, I think. No, the resource. So when there are multiple threads are communicating between each other, then there is a chance that they can conflict with each other. So we have to monitor their communication. We have to monitor in such a way that we have to ensure uh, that one thread only holds one resource, not multiple resources, which is basically the mutual exclusion. We have to ensure we don't allow one thread to write the data on the other. Each object in Java is associated with a monitor which a thread can lock or unlock. Only one thread at a time may hold a lock on the monitor. Synchronization provides a simple monitor facility that can be used to provide mutual exclusion between Java threads. The support is built in, like thread multi-threading is built in Java. Similarly, synchronization support for these threads is also built in Java. Thread class methods, you have current thread, get name, get priority, interrupt, interrupted, alive, is daemon, set name, set priority, sleep, and start. Current thread returns the reference of the currently executing thread. Get name gets the name of the thread. Get priority returns the priority of the thread. Interrupt is used for interrupting a currently executed thread. Interrupted allows us to test whether the current thread has been interrupted or not. Is alive is to test whether the thread is alive or not. Not thread, but thread. Okay. Is daemon is used for testing whether a thread is a daemon thread or not. Set name changes the name of the thread to the new name. Set priority changes the priority. Sleep causes the currently executing thread to sleep. Start used to begin execution of the thread. Java thread model. You have start, ready, running, and dead. So when the thread starts executing, when the thread starts, it's in the ready state. If it's not interrupted, it'll continue running and then finally finish execution. But if it's interrupted because of IO request or it requires some resource, it goes in the waiting state. So you have new ready to run. So it gets a CPU time. Running a thread is running state, which is under execution. Suspended, temporarily inactive or under execution. Blocked, blocked because waiting for a resource. And terminated, and it finishes its execution and comes to a halt. Thread priorities. So Java assigns each thread a priority. Thread priority determines how a thread should be treated with respect to others. It's an integer that specifies the relative priority of one thread to another. A thread's priority is used to decide which thread A thread can voluntarily relinquish control by explicitly yielding, sleeping, or blocking the pending input or output operations. In this scenario, all other threads are examined, and the highest priority thread is ready to run, gets the chance to use the CPU. Inter-thread communication to avoid wastage of precious time of CPU or to avoid polling, Java includes the inter-process communication mechanism via wait, notify, and notify all. These methods are implemented as final methods, so all classes have them. These methods can only be called from within the synchronized method. Wait tells the calling thread to give up the monitor and go to sleep until some other thread enters the same monitor and calls the notify or notify all. Notify wakes up a single thread. Notify all wakes up all threads that are waiting for the object's monitor. The highest priority thread will run first. Yep. Obtaining thread state. The getState method of the thread class returns the thread state. This method is designed for monitoring the system state and not for synchronizing control. Number and string, you have a number class and it's used. Number class allows us, number class is an abstract class which is placed in java.lang package. So java.lang also has the runnable and thread class as we discussed earlier. So the same package has java.lang.thread and java.lang.runnable. Okay, so this is an abstract class which is placed in this package. It has four abstract methods: int value, long value, double value, float value, and two concrete methods: byte value and short value. So what is this used? The constants defined by the number class, such as min value and max value, that provide upper and lower bounds of the data are very much useful. So this number class basically is placed in java.lang package. It has four abstract methods: int value, long value, double value, and float value, and two concrete methods: byte value and short value. The uses of number class is that the constant defined by this class, min value and max value, provide upper and lower bounds of the data type, which are very much useful. Number class object can be used as an argument of a method that expects an object, and used for manipulation, for converting values from primitive type, etc. Okay, so let's move on. String class represent character strings. All string literals in Java programs such as ABC are implemented as the instance of this class. Strings are constant, their value cannot be changed after they are created. String buffer supports mutable strings. Because string objects are immutable, they can be shared. These are the methods of the string. String builder class. I think we'll do the recap tomorrow from here. Let's move on to from where we left. So I think we have to do object serialization today. So may I like you to read? I'm tired reading. So I'll just open it. Where is it? Okay.
Object serialization is a mechanism of converting the state of an object into a byte stream.
Okay.
In object serialization, an object can be represented as a sequence of bytes that includes the object's data as well as information about the object's type and the types of data stored in the object.
Mm-hmm.
After a serialized object has been written into a file, it can be read from the file and deserialized. There is the type information and bytes that represent the object, and its data can be used to recreate the object in memory.
Okay, let's remove these things first. Object. So object selection mechanism of converting the state of an object into a byte stream. This is the key thing. Assignment. Such an object can be represented as a sequence of bytes. Object can be represented as a sequence of bytes that includes object's data as well as information about the object's type. So object's data and information about object type and the types of the data stored in the object. After serialized object has been written to the file, it can be read from the file and deserialized. Type of information and byte that represent the object and its data can be used to recreate object in the memory. Okay. So serialization, deserialization. So once it's serialized, it can be read from the file. So this is an object, um, and as we know that serialization means that converting the state of an object into a byte stream. So here we are doing serialization. We are converting object into a byte stream. Okay. So after serialization, which means serialization has been done. Now it's converted to byte stream. Now it can be read from a file. So these are a file and it can be read from here. And it can be deserialized also, which means again from byte stream it'll be converted back to object. That's what it's talking about. And its data can be used to recreate the object in the memory. Okay, so this byte stream stays in the memory. Okay, so how does an object serialization work in Java? Let me just add the animation quickly. Where are you? Yep, let's get back. Yes, may I please go on?
How does object serialization work in Java? An object is eligible for serialization if and only if its class or its parent implements either java.io.serializable or java.io.externalizable library interface.
Okay.
In serialization process, we convert an object state into a byte stream so that it can be transferred from one JVM to the other and revert the byte stream back into the original object.
Okay, so I think this is clear. This is the same thing what we discussed before, is that in order for us to convert into basically in serialization we convert the object state into byte stream, and why we convert it so that you can transfer it to from one JVM to another, and it can run on multiple machines also, different JVM of different operating systems. And if you want to deserialize it, you can convert that byte stream back to the original object. This is the condition of a object that can be serialized, that it can be serialized only if that particular class, its class or its parent, they have to implement either java.io.serializable or java.io.externalizable interface. Okay, go on.
Serializable is a marker interface, contains no methods that tells JVM that the object of the class is ready for being written to and read from a persistent storage or over the network.
So in the previous example, this is the diagram we were looking at, and we spoke about that once it's serialized, which means once it's converted to the byte stream, it can be read from a file. Okay, and that's what it's talking about here. That once it's serialized, it's ready for being written to or read from. Either you can write or read from a persistent storage. So what is persistent storage? A file is a persistent storage. Okay, so it can be read or it can be written on that, because now it's in a state of uh, what's the state called, byte string. Yeah. And serializable is, this is the interface it's talking about here, java.io.serializable. So it's saying that it's a marker interface that tells Java virtual machine that object of this class is ready. Now you can read it or write it from a file. Yep.
By default, JVM takes care of writing and reading the serializable objects. The serialization deserialization are via the following two methods. Object output stream dot write object that writes serializable object to output stream. Object input stream dot read object that reads, constructs and returns an object from the input stream.
Okay. Let's just quickly make these guys bold so it's easily readable. Cool. Now this is more readable. Let's move on. These all questions are from the assignment. Okay, let's go on.
Use of object serialization in Java. Communication. If you have two machines that are running the same code and they need to communicate, an easy way is for one machine to build an object with information that it would like to transmit and then serialize that object to the other machine. It's not the best method for communication, but it gets the job done.
Okay, so if there are two machines and they're supposed to in exchange some data, what it can do is first machine can serialize an object, basically put all the information in the object, serialize it, convert it into byte. What was called byte stream, yeah. Convert into byte stream, and then pass it on to the other machine. So that's what it's talking about here.
Persistence. If you want to store the state of a particular operation in a database, it can be easily serialized to a byte array and stored in the database for later retrieval.
Okay, so when I've been working with the PHP database, I know that, for example, an array can needs to be serialized before it's stored into the database, and then when we want to read the data, we unserialize it. And PHP also has some functions called serialize and unserialize. So just talking about it that if you want to store something in database, you can store it into a serialized form. Okay.
Deep copy. If you need an exact replica of an object and don't want to go to the trouble of writing your own specialized clone class, simply serializing the object to a byte array and then deserializing it to another object achieves this goal.
Okay.
Caching. Really just an application of the above, but sometimes an object takes 10 minutes to build but would only take 10 seconds to deserialize. So rather than hold onto the giant object in memory, just cache it out to a file via serialization and read it in later when it's needed.
Okay.
Cross JVM synchronization. Serialization works across different JVMs that may be running on different architectures. Saving program states on disk. For example, storing state of a game. Sending data over network in the form of objects, for example, sending messages as objects in chat application.
Okay, so the key thing over here in using the why the object selection is used, it looks like when you need to pass the data from one machine to another or save into database or cache it. So at that point of time, this object selection is really useful. Let's talk about Java API. There's no. We'll finish it by 7:30. Okay, so I'll do it for like another 20 minutes.
Okay.
Okay.
The Java API is a group of pre-written packages, classes, interfaces, along with their methods and attributes.
Mhm.
Collections API in Java is used for storing and manipulating a group of objects. Collection framework is a group of classes and interfaces to store and manipulate the group of objects. Various operations like searching, sorting, insertion, and deletion can be performed on these objects. Various classes such as ArrayList, vector, stack, and hash set, etc. are provided by the collection framework. Also, there are many interfaces such as list, queue, set, etc. available in collection framework.
Okay, so we're talking about Java API, which is nothing but a group of pre-written packages, classes, interface, which contain methods and attributes that we can use. So collection API is used for storing and manipulating a group of objects, and this is a hierarchy of that. It has got iterable, collection, list, queue, set, and as you can see, this key, this all the gray ones are the classes, and the white ones are the interfaces. So iterable is an interface. You have collection, interface, list, queue, set, DQ, sorted, and rest of them are classes. This is the hierarchy in Java for collections, and they contain methods basically which helps us store and manipulate a group of objects. Okay, so now we have date and time.
Java supports creating and modifying the date and time using primarily two packages, java.time and java.util. The package java.time was part of a Java 8 release, JSR 310, that introduced the new immutable classes, solving the shortcomings of the legacy java.util.date and java.util.calendar classes.
Okay, so there were some issues with the previous Java util.date and Java util.calendar classes. So to solve that, in Java 8, they released just one package called java.time, and this will basically help you get all the methods for date and calendar, and whatever issues that were there in these two are no longer present in java.time. So we can directly use Java and time, java.time package. So this is the java.util.date constructors. You can create a new date object using new date, okay, and it represents the current date and time by default. Then you have date long milliseconds. This creates a date object for a given milliseconds since January 1st, 1970. This so in programming, this is where the time starts. When you create timestamps, um, timestamp is basically number of milliseconds since this date and time. So that's how we calculate. We take this unit as our source of truth. Then you have date has certain methods like after, before, clone, compare to, equals, from, get time, all of these. So you can check all of these. After test if current date is after the given date. Before test if current date is before the given date. Clone returns the clone object of the current date. Compare to compares two dates. Equals compares current date with the given date for equality. From returns an instance of a date object from that particular date. So similarly, you have different times basically. Set time will allow you to change the current date and time to a given time. Then we talk about date and time programs. So if you had to write a date and time program using the packages that we spoke about, you can use java.util.date, and you can import that package, and now this particular class will be available to you. So as we discussed, we can create an object. So here is your date constructor. You can create an object for that. So of type date, the name of the variable is date. You use new date to create an object for date class. You want to print in today's date, just use the println and then pass this object. It will print that. If you want to retrieve the number of milliseconds since that particular date, you can just call date.getTime, store it in the millisecond variable. It's a custom variable. And then if you want to create a date object with a specific time, you can pass that information here. So it's in a millisecond value. So this will return the date object with the given time what you passed here. You can get the time using get time function. We already done that here. You can compare the dates. So whatever the current date is will be held inside of this object. So the object variable dot compared to and the new object variable. So here we passed another date. So now we have two date objects, this date and this date one. So now we are comparing using compare to functions. It's going to compare and give us the result. If the result is 0, both dates are same. So if this method returns 0, which means both dates are same. If it returns 1, then this one is later than this one. And then otherwise, if it's not 1, then uh, this one is earlier than this date. Okay, so now you can see that this is all are printed here. Right, then you talk about set interface. Fix this. Okay, go on.
Set interface. A set is a group of dissimilar objects. Java provides set as an interface that extends the collection interface, and hence it has access to all the methods inherited from the collection interface. Unlike the list interface, sets cannot contain duplicate items. Some of the commonly used methods of the collection interface that's also available in the set interface are add all, iterator. These classes are defined in the collections framework and implement the set interface are hash set, linked hash set, enum set, and tree set.
Okay, the set interface is basically a group of dissimilar objects, and it extends the collection interface. And you already read about the collection interface is they're used for grouping the objects together. And whatever methods collection interface has, this will also have that because it's just extending the collection interface. One of the key things is that it cannot contain duplicate elements. There are common methods that are available like add all, iterator. Some of the classes are defined in collection framework and implement the send interface are hash set, linked hash set, enum set, and tree set. Example of implementation using hash set is this. So you use set, then the type, animals is the name of the variable, new hash set. Here we have created a set called animals. We have used the hash set class to implement set interface. Iterator in Java collection framework. Yeah, go on.
In order to pass over the elements of any collection, we can make use of iterable interface, which is the root interface of the whole collection framework. The iterable interface is extended by the collection interface. Hence, all the interfaces and classes of collection framework implement this interface. The most important feature of iterable interface is to offer an iterator for the collections. Only one method, which is abstract and whose name is iterator, is contained in this interface. It returns an object of type iterator.
Okay, I'll just recap that. So iterator in Java collection framework. So we're just talking about collection framework right now, and in that there are different classes, there are different interfaces that are available. One of them implements another. So if you go back and look at the hierarchy, where is it? Yeah, this is the one. So you see that there's the interface, iterable, right, which is kind of implementing this collection. And we looked at linked list. What else we looked at? Hash set, links hash set. Yeah. Okay. So we're talking about all of these classes and interfaces inside of the collections. Collection API is used for storing and manipulating the group of objects. Okay. So recapping this, in order to pass over the elements of any collection, we make use of iterable interface, which is root interface of the whole collection framework. You must have seen in that the previous example, the iterable was on the top. It's extended by collection interface. So you must, if you remember, you had iterable, and below that there was collection. Hence, all the interfaces and classes of collection framework implements this interface. Most important feature is to offer iterator for the collections. Only one method, which is abstract, whose name is iterator, is contained in the interface. Returns object of type iterator. Now I talk about hash set. Go on.
Java.util.hashSet class is a member of the Java Collections framework which implements the set interface. Its purpose is to create a collection and store it in a hash table. Each element in set has a unique value of its own, called hash code, which is used as an index at which element associated with that hash code is stored. Hash code is obtained by converting the informational content into a unique value known as hash code. Hashing ensures that the execution time of operations like add, remove remain constant even for a set of bigger size. The elements are inserted in hash set irrespective of the order of insertion, and the order depends on the hash code of elements.
Okay, just a repeat of that. So the java.util package has a hash set class, which is again a member of Java collection framework. It implements a set interface. The job of this is to create a collection and store it in a hash table. Okay. Each element in a set has unique value, and that value is called hash code. This is used in an index. So whatever hash code is created is used as an index, and that index, so the element is associated with that hash code. So how do we create this hash code? It's obtained by converting informational content into a unique value. So whatever information is there, we convert it into a unique value, and that'll be your hash code. So what's the purpose? What's the benefit of this? It ensures that the execution time for operations like add, remove, even for bigger size of data, it's the same. Now, how are the elements inserted? Um, so elements are inserted in hash set irrespective of the order of the insertion, and the order depends on the hash code of the element. Okay, let's go on this one, Sumaya.
The hash set and tree set both classes implement the set interface. The differences between the both are listed below. Hash set does not maintain any sequence of elements added to it. Tree set maintains ascending order of implements. It is implemented by hash table. It is implemented by a tree structure. Performance is better than tree set. Tree set performance is not as good as hash set. Hash set is backed by hash map. Tree set is backed by tree map.
Okay, so in the previous one, we learned about the performance here. It ensures execution time remains constant. So that's why we're talking about performance is better in the hash set compared to tree set. Okay, then it does not maintain any sequence of the elements added to it. And this is the last line says that elements are inserted irrespective of the order of insertion. So order doesn't matter. It depends on the hash code of the elements. That's what we're talking about. It does not maintain any sequence of the element added to it. And this is just the reverse of that. Okay. So let's just quickly make these things bold. Member of Java collection framework. Purpose is what? To create collection and store it in hash table. Each element in set has unique value. Each element has unique value. Okay. Hash code obtained by converting information content into unique values. Execution time remains constant. Elements are inserted irrespective of the order of insertion. Okay, we'll do this last and then we'll call it a day. Okay, Sumaya?
The map interface of the Java Collections framework provides the functionality of the map data structure. Elements of map are stored in key value pairs. Keys are unique values associated with individual values. A map cannot contain duplicate keys, and each key is associated with a single value. We can access and modify values using the keys associated with them. A map is suitable if we have to search, update, or delete elements on the basis of a key. In the diagram, we have values United States, Brazil, and Spain, and we have corresponding keys US, BR, and ES. Now we can access those values using their corresponding keys.
Okay, so map interface is again a part of the Java collection framework, which is what we're talking about. What is this job? It provides functionality of map data structure. Okay, so elements are stored in key value pairs. That's the main thing. And they are associated with individual values, cannot contain duplicate keys, and each key will have a single value. So how can we access or modify the value? We can access or modify using the keys. Okay. Suitable if we have to search, update, delete basis of keys. So suitable for searching on the basis of key. Okay, so example, we've already seen that. Yeah, I think we can do the rest of it from tomorrow. So tomorrow you will be covering the question paper, this question, right? 2NF, 3NF, and then also the what was
The one
that?
from the assignment.
2B. Yeah, assignment 2B, and we can start it at the same time, which is 5 o'clock. I hope that's okay.
Okay,
Cool then. Thanks, Amaya. Take care. Bye.
okay, thanks.
Bye.